All right, so we're going to go over the fourth question now. The fourth question is basically an organic question. So the first thing they want you to do is they want you to name this compound. So make sure that you are careful about this. It does have a double bond. So it has, let's see, with the double bond included, 1, 2, 3 should be the longest chain. Even if you go the other way, 1, 2, 3, we're going to have to start numbering from the double bond because that's our functional group. So technically, it would be 1, 2, 3 would be prop. All right, and then we've got the double bond at the first one, so we can do -1 ene. Now we've also got another, we've got a substituent group. So we've got a methyl here, and that's going to be on the second carbon. So 2-methyl, like that. Now the thing is, because there's really no other way to arrange this structure, you could have also just written methylpropene. Because if you have a methyl group and you have 3 carbons, really once you realize that the double bond has to be at the end, and if there's no other option, I mean, even if I had the double bond right here, it'd still be the first carbon because that's how we name it. So if you had methylpropene, that would still get you a mark. Now, the next one is a polymerization question. So it's asking you to draw a section showing 3 repeating units of a polymer that can be formed from compound A. So if we take something with a double bond and we break that double bond, we can now attach 2 more atoms to the structure. So what ends up happening is if you break the double bond, you can create another bond here and you can create another bond here. So it wants you to show 3 repeating units. So what I do, let's see. Okay, so you've got a carbon and you've got another carbon. This is where the double bond was. Well, when I look at that right there, okay, so this carbon right here on the outside is attached to 2 hydrogens, and then this carbon is attached to 2 methyls. So that's what I'm going to draw. So this one has 2 hydrogens. This is where the double bond would have been, but we're breaking it. And then we've got a CH3, and then we've got another CH3. All right, so now, well, we've broken that double bond, so now we can make another attachment here. So you're basically drawing the same thing over again. This carbon has 2 hydrogens on it. The other carbon has methyl groups. And you just draw it again because it's asking for 3 repeating units. And then the brackets just show that it could be continuing on and on and on. All right, so that would earn you a mark. You could have also put it into condensed structure, so that would be where you write CH2, and then that carbon is attached to 2 methyls, so parentheses CH3 2, and then you just write that on and on and on until you get the 3 units. All right, so compound A is flammable. Formulate the equation for its complete combustion. All right, so if you just go and count and you say, okay, there's 4 carbons, and then there's going to be 8 hydrogens. It's combustion, so reacted to O2. It's a hydrocarbon, so you're gonna make CO2 and water, and it says complete combustion, so you don't need to worry about the carbon monoxide. And then you just need to go through and balance it. So you would have to have, in order to get the mark, you have to have the correct equation, you also have to have it balanced. All right, so compound B is related to compound A. Well, if I look, compound A had this formula. So does this one. They are isomers of each other. So when you have the same molecular formula, but then you have different attachments, they're going to be isomers. So technically, you could say they're structural isomers, but they're also functional group isomers. because now we don't have the double bond. So you just needed to say at least one of those. So they're isomers because they have different connectivity, but they have the same molecular formula. All right, the next question says, suggest a chemical test to distinguish the two. Well, compound A has a double bond, compound B does not. So we could react it to bromine. So if you reacted to bromine, that would be your test, okay? So that would be 1 mark right there, okay? Now in the mark scheme, it does say like in the dark, okay? But you don't have to say that for this, but you do need to say like you're adding bromine to it. Now, the observation that you should see with A is that the orange, red, brown color goes to colorless. So the orange color goes to colorless. Now, in the mark scheme, they do specifically say do not write clear. So it's without color. So that's what we're going to say. So if it goes to from a 1 color to nothing, you have to say colorless, not clear. Now with B, well, nothing should happen. So I have to add the bromine, and then there would be no change in color. All right, so the last part of this question, we're asked about the spectroscopy. So predict one difference in the IR spectra and one difference in the H&MR. Okay, so when you're writing this, okay, this is 2 marks. So you get 1 mark for this, 1 mark for this. But in order to get the mark for this, and then it's the same thing here, you have to make a comparison. You can't say compound A this. You have to talk about both compounds. So for this particular one, so for A, we'll refer to your data book because you do have a data book for this. So A would have a peak and you have a data book, go refer to that number. It's 1620 to 1680 because we know the main difference in this compound is A has a double bond. So you would have to state that A has this particular peak at this amount. So go and refer to your data book for that. And then B would not. So that's the part that people miss out on. A has this peak, B does not. You have to actually say the last part where you're comparing it to B. Now, for H&MRs, well, if you go back and you look at the spectrum, or look at the compound itself, let's go do that. Okay, so H&MRs show you peaks for the different types of hydrogens. So if you look at this compound right here, all of these hydrogens are equivalent to each other. They're all on a carbon, so there's 2 hydrogens on the carbon bonding to another carbon which has got 2 hydrogens on it. So they're all equivalent to each other. So we're only going to see 1 signal for that. Now for this compound, we're definitely going to have more signals than 1. And if I look, it looks like I'm going to have 2 signals. I'm going to have the 2 hydrogens here, and then I'm going to have the 3 hydrogens on the methyls because each of these hydrogens is bonding to a carbon, double bonding to this. So there should be 2 signals for that. Now, in order to get the mark here, you only have to mention that compound B has 1. You do have to talk about compound A, but you don't have to say that it has 2. You could say that it has more. Okay, now the other options that you could have done with the H&MR, you could have actually gone and looked at the chemical shifts and listed some of those things. But really the biggest clue for this is that it's the number of signals. Okay, so a sample of compound A was prepared in which C12 and the CH2 group was replaced by C13. So the mass is different. Okay, so state the main difference between the mass spectrum of this sample and then the normal compound A. Well, the new prepared sample okay, the molecular ion peak will be the big difference here. So you could have worded this a couple different ways. You could have said that if you had the molecular ion peak and it's higher, you could have said that it's 1 higher. You could have also listed the mass, like gone to go back and look at the formula to see what it was. It's molecular ion peak, that's higher. So if you were more specific than that, then that's absolutely fine. Okay, state the structure of the nucleus in the orbital diagram of carbon-13. All right, so the number of protons, well, if you go look up the atomic number in carbon, it's 6. 13 minus 6 would give me 7 neutrons. And then for your orbital diagram, just remember you're going to have one arrow going up, one arrow going down. So for this, you have, it's 1s2, 2s2, and then there's 2p2. So one arrow going up, one arrow going up. Don't put them in the same box because that's a violation. All right, and then the last question. Draw 1s and then draw 2p. Well, 1s would be a sphere. P, any kind of p orbital, doesn't matter if it's 2 or 3, it's going to have a dumbbell shape. So you could have had it going this way. You could have also had it going in the horizontal direction.